Yes, dear students, in the previous session we have discussed about formation of partial differential equation by eliminating arbitrary constants. In this session, we will discuss about formation of partial differential equation by eliminating arbitrary functions. Here, let's see the problem. Form partial differential equation for the function z equal to f of x square plus y square by eliminating arbitrary function. Here, this is the given equation. Here, f is the arbitrary function. We have to construct partial differential equation. In that, we have to eliminate this arbitrary function f. It is very simple problem. Consider the given problem or given equation z equal to f of x square plus y square, and one time differentiate with respect to x. Differentiate partially with respect to x. We know that derivative of z denoted by dou z by dou x, its notation is p, and equals to, in the RHS we have function f, its derivative is f dash of function f, derivative is f dash of x square plus y square, and inside the function we have x square plus y square. We have to differentiate this term. X square derivative 2x, y is constant, its derivative 0, because while differentiating partially with respect to x, other variables are constants, and so we get p equals to f dash of x square plus y square into 2x. Similarly, differentiate equation 1 partially with respect to y. Derivative of z is dou z by dou y. We know the symbol is q, which is equals to derivative of f is f dash of x square plus y square, and x square plus y square derivative. While differentiating y, x is constant, its derivative 0, y square derivative 2y. So we get equation for p and q. So called as 2 and 3. By dividing 2 by 3, here p by q. In the LHS we have p divided by q equals to f dash of x square plus y square into 2x in the numerator. In the denominator, f dash of x square plus y square into 2y. So here f dash get cancelled, 2 get cancelled, only remaining thing is x by y. P by q equal to x by y. So cross multiply the denominator terms. So we get p into y equal to q into x. If you transfer q into x to LHS, we get py minus qx equal to 0. This is the required partial differential equation. In this equation, partial differential equation, p and q are partial derivatives, and here there is no arbitrary function or arbitrary constant. So this is the required partial differential equation. Yes, let's see another problem. Obtain partial differential equation by eliminating arbitrary function for the equation z equal to y square plus 2 into f of 1 by x plus log y. Here f is the arbitrary function. Right, solution. Given that, write down the given equation, and we have to eliminate this arbitrary function f. For that, differentiate partially with respect to x. Derivative of z is dou z by dou x, its notation is p equal to, here while differentiating with respect to x, y is constant, its derivative 0. So next term 2 into derivative of f is f dash of 1 by x plus log y into, so inside term derivative 1 by x derivative is minus 1 by x square, and log y derivative 0 because we are treating y as constant. Here p equal to 2 into this function. In the denominator we have x square, cross multiply to this LHS, we get p x square equal to, here is minus, therefore minus 2 into f dash of 1 by x plus log y, call it as equation 2. Similarly, differentiate the given equation partially with respect to y. So derivative of z is dou z by dou y equals, its notation is q equal to, here y square derivative 2y plus, here f involves both the variables x and y, therefore we have to differentiate this one, plus 2 into derivative of f is f dash, so 1 by x, here inside the terms derivative 1 by x is constant, therefore its derivative 0, log y derivative 1 by y. Here cross multiply this transfer this 2y to LHS, so it becomes q minus, here it becomes q minus 2y equal to remaining terms 2 into f dash of 1 by x plus log y, and in the denominator we have y, cross multiply this term to LHS, we get q minus 2y into y equal to 2 into f dash of 1 by x plus log y, call it as equation 3. We can observe here in the RHS of equation 2 we have the function f dash. Similarly in the RHS of equation 3 we have f dash. By dividing these two terms with these two equations, it gets cancelled. So by dividing 2 by 3, equation 2 px square, in the LHS of equation 3 we have this term equal to RHS of equation 2 divided by RHS of equation 3. Here 2 cancel, f dash cancel, only minus 1. So cross multiply this term to here px square equal to minus of q minus 2y into y. So denominator term cross multiplied to 1 minus 1. So multiply minus q y minus into minus plus 2y square, because y into y square. So transfer this term to LHS, px square plus qy equal to 2y square. This is the required partial differential equation, because here p and q are partial derivatives and here there is no arbitrary function. Thank you.